2-6, ratios, rates, and conversions. So our objective for this section is to find ratios and rates, and to convert units and rates. And our essential understanding is that we can write ratios and find unit rates to compare quantities. We can also convert units and rates to solve problems. So in this section, we're primarily going to be dealing with taking one thing and changing it into something else, something that makes more sense or can help us understand the situation a little bit better. Okay, so we're going to look at ratios, which is something that compares two numbers by division. The ratio of two numbers A and B, where B is not 0, can be written in three ways: as a fraction, as a quantity with a couple dots in between them, or by A to B. Okay, all of these mean the same thing. Okay, so it doesn't matter how the ratio is used. Primarily, we see the one with the fraction the most. Okay, we can use the colon a little bit, or we can use the 2 a little bit here and there, but we're going to use mostly the fraction. For every A units of one quantity, we have B units of another quantity. That's what a ratio means. And we can also think about a ratio as a multiplicative relationship. For example, if the ratio of the number of boys to the number of girls in the class is 2 to 1, and usually when we have the symbol right here, we usually say 2 to 1, okay? Just like we would up there. Then the number of boys is 2 times the number of girls, because we have 2 boys for every 1 girl. That's what that means, okay? So the ratio is 2 to 1. A ratio that compares quantities measured in different units is called a rate. A rate with a denominator of 1 is called a unit rate. Okay, so we didn't look at the solve it, but let's look at a problem. Okay, so you're shopping for t-shirts. Which store offers you the best deal? 25 bucks for 2 shirts, 45 bucks for 4 shirts, 30 bucks for 3 shirts. Well, in order this to figure it out, we're going to write each price as a ratio, and then write the ratio as a unit rate to compare them. Okay, so store A, right, we're going to have $25 for 2 shirts. Okay, and if I simplify that to a unit rate, divide the 25 by 2, I get $12.50 for 1 shirt. Okay, that's a unit rate. Okay, because it compares something to 1. Huh? So next, for store B, okay, we have $45 for 4 shirts. Okay? And if I divide this, I get that this is equal to $11.25 for 1 shirt. Okay? So far, that one's good. That one's better, right? Rather pay $11.25 a shirt than $12.50 a shirt. Store C gives me $30 for 3 shirts, and that works out to be $10 for 1. Okay, so changing these all to a unit ratio of 1 shirt lets me compare the prices. Oh, whoops. So $12.50, $11.25, and $10, and it turns out that store C is the best deal. Okay. Let's look at the solve it. If store B lowers its price to $42 for 4 shirts, does the solution change? Well, not really, because $42 for 4 shirts gives me $10.50 for 1 shirt. So stores store C is still the best deal. If this goes maybe down to 39 bucks for 4, now it would be a better deal. But right now it's not. Okay? So to convert from one unit to another, such as from feet to inches, we need to multiply the original unit by a conversion factor. That produces the desired unit. So a conversion factor is a ratio of two equivalent measures in different units. A conversion factor is always equal to 1, such as 1 foot to 12 inches, because there are 12 inches in a foot. See the table on page 814 for some common equivalent units. Luckily, I included that table. Okay, it came out a little pixelated, but hopefully you can make it out. And most of these you should be kind of familiar with, just as a matter of general knowledge. Okay, so you should kind of know that there are 12 inches in a foot, 36 inches a yard, 3 feet in a yard. This one is probably one of the more useful ones when we deal with length conversion, and it's one that not everybody really knows. There's 5,280 feet in a mile. With our U.S. units are a little confusing. There's numbers all sorts of places. With metric, you just have to remember the prefix and how they relate back and forth to each other, because they're always going to be in terms of powers of 10. Okay. For area, usually we don't usually go right back and forth in here with 144 square inches square foot or 9 square foot square yard. Usually you just go linear feet and then multiply to get area. This one is a weird one. You might hear that a lot, is that there's a measure of area called an acre, mostly used in real estate and property. And there are 43,560 square feet in 1 acre. And you could also do that with yards as 4,840. And when we talked about the same sort of space with the metric, it's called a hectare. Okay, so we have that right there. Okay. Volume, not super useful. Liquid capacity, you should kind of know a few of these, that there's 8 fluid ounces in a cup, 2 cups in a pint, 2 pints in a quart, 4 quarts in a gallon. Okay, if you ever go to the supermarket, right, you should recognize some of these things when you're buying any sort of liquid. Mass, 16 ounces in a pound, 2,000 pounds in a ton. Temperature, 32 degrees is the freezing point of water, 98.6 is normal human body temperature, and water boils at 212. Okay? So, weird numbers for freezing point and boiling point. Metric is a little bit better with Celsius because 0 is freezing, 100 is boiling. Nice and easy to remember. These are our customary conversion factors. Okay, and most of the time, if a text or if something wants you to use those factors, it will give them to you. Any of these right here. And then, of course, time. This one should kind of be a little more obvious. And this is the one thing that doesn't have 2 different types of scales. 60 seconds a minute, 60 minutes an hour, 24 hours in a day, 7 days in a week, and 365 days in a year, 52 weeks in a year, 12 months, 10 years in a decade, 100 years a century. All that stuff you should kind of know. Okay? So, what is the given amount converted to the given units? Okay, so in order to do this, we're going to choose and multiply by the appropriate conversion factor. The appropriate factor will allow you to divide out the common units and simplify. Okay, so that's a little hint right there. So for part A, I want to turn 330 minutes into an hour. Okay, so I'm going to start by, always start with the initial amount, not 300, 330 minutes. Okay, then I'm going to multiply by 1, by something that will change where I'm starting minutes into what I want hours. Well, I know that there are 60 minutes in an hour. So I want to wind up with hours. So whatever you want to wind up with, whatever unit you want to wind up, goes on the top. So this is 1 hour is 60 minutes. Now, when I multiply these together, right, this is over 1. When I multiply these together, um, those two things will cancel out, and it will give me 5.5 hours. 330 times 1 divided by 60. Okay? Kilograms to grams. Kilograms to grams is nice and easy. We start with 15 kilograms, and I multiply by there are 1,000 grams in 1 kilogram. Kilograms cancel out, and we're left with 15,000 grams. Okay? Last one. 5 feet, 3 inches to just inches. Well, don't make the mistake that this is 5 feet plus 3 inches. Okay? So the 3 inches is already in inches. So all I need to do is change the 5 feet. So that's 5 feet times there are 12 inches in 1 foot. The foot cancels out, and we're left with 60 inches. But don't forget to put that 3 back in. So the total here would be 63 inches. Okay? Our got it problem. What is 1250 centimeters converted to meters? Okay? So we start with 1250 centimeters converted to meters. My conversion factor is that there's 1 meter in 1,000, sorry, 100 centimeters. Centimeters cancel out, so my answer is 100, 12.5 meters. Okay? And normally, if you have to use a conversion factor that you're not sure of, you can always just look it up on the internet. Okay? So in this problem, in problem 2, notice that in each time that we did it, that the units for each quantity are included in the calculations to help determine the units for your answers. This is called unit analysis or dimensional analysis, okay? And you'll use this a lot, maybe not even math, maybe more in chemistry and biology, okay? So converting between two different systems is a little bit harder because then we need to use a conversion factor that's given. So the CN Tower in Toronto, Canada is about 1,815 feet tall. How many meters is the tower? Okay, so I know that is 1,815 feet tall, and I have my conversion factor right here that these two are equal to each other, and I want to wind up with meters, so I'd multiply by 1 meter over 3.28 feet. Okay? Cancel out the feet, and we get 1,815 divided by 3.28 turns into 553.4-ish meters, right? Meters is the unit that's left over. Okay? So the trickiest part here is not the math, it is the units, making sure that you're putting the right units and you're not getting confused. Okay? So a building is 1,450 feet tall. How many meters is it? So same thing, start with 1,450 feet. We multiply by, now if I had done it this way, notice that the feet don't cancel. Feet times feet is feet squared. Okay, so just make sure that you're doing the conversion factor the right way. 1 meter over 3.28 feet. Okay, now the feet can cancel, one on the top, one on the bottom, and we have 1,450 over 3.28, which gives me 4 42.1 meter. Okay. Part B says monetary exchange rates change from day to day, which is true. On a particular day, the exchange rate for dollars to euros was $1 is equal to 0.63 euros. About how many euros could you get for $325? So we're going to start with $325. We're going to multiply by, well, 0.63. The symbol for euros is, it's kind of hard to make. It's kind of something like that. It's a little, I don't have the, can't make it as fine as I want to, but it's fine. Over $1. Dollars cancel out, and we have 325 times 0.63. And so on this day, you would get 204.75 euros. Okay? So definitely less than you have in dollars. We can also convert rates. For example, you can convert a speed in miles per hour to feet per second. Because the rates compare measures in two different units, you must multiply by two conversion factors to change both the units. Okay? And when you do this, you have to be careful that you are not multiplying or dividing by the wrong number. Okay? So let's take a look. Student ran the 50-yard dash in 5.8 seconds. At what speed did the student run in miles per hour? So right now, we're talking about yards per second. So if I write this as a ratio or a rate, I have 50 yards in 5.8 seconds. Okay, so I want to change from I want to go from yards per second to miles per hour. Okay, and if I look back at my table, I can see that here's what I want: 760 yards, 1 mile. So I know that in 1 mile there's 1760 yards. 1 mile, 1760 yards. And notice I put the yards on the bottom so that way these two would cancel out. Now if I just got an answer right here, it would be in miles per second. I don't want miles per second. I want miles per hour. So I'm going to multiply by another conversion factor to change seconds to hours. Well, there are 3,600 seconds in 1 hour, right? If you don't remember that, you can say that there's 60 seconds in a minute, 60 minutes in an hour, okay? But we can put both of those conversion factors together. The seconds cancel out, and now if you look at your units, we're left with miles and we're left with hours. Now all we have to do is multiply and divide. So we now have 3,600 times the 50, divide by 5.8, and then divide again by 1760, and you would get about 17.63 miles per hour. Okay? Or if we want to write it, we could write it as 1763 miles over 1 hour. But typically, when we write rates, we're going to write it like this. And miles per hour should sound pretty familiar, something you would see on your speedometer driving a car. An athlete ran a sprint of 100 feet in 3.1 seconds. So we're going to go 100 feet in 3.1 seconds. Again, we're going to go to miles per hour. So we need that there are, in 1 mile, there are 5,280 feet. Again, if you can't remember that, you can look that up. And in 1 hour, there are 3,600 seconds in 1 hour. Okay? Seconds cancel, feet cancel, and I'm left with miles per hour. So that's 3,600 times 100. Divide out the 3.1 and the 5280 to give me about 22. Okay, it was 21.99, so about 22. So in problem 4, one student multiplied the conversion factor miles, yards, 60 seconds per minute, 60 minutes per hour. And again, right, I started with, I believe it was 50 yards in 5.8 seconds. So that's 50 yards in 5.8 seconds. The yards cancel, the seconds cancel, the minutes cancel, and I'm again left with miles per hour. There's just one extra step here. Okay, so we have 2 conversion factors instead of the 1. And if I multiply these together, you could see that the minutes would cancel out, and I would get 3,600 seconds in 1 hour, which is the conversion factor I used in the first problem, or in the first part. Okay, so if you wanted to do it this way, let me clear this out. If you wanted to do it with this method right there, that's not a problem. It's just one extra step. Okay, so our lesson check. So to figure this out, which is a better buy, 6 bagels for $3.29 or 8 bagels for $4.15, you would just divide 329 by 6, 415 by 8, and see which one gives you the better deal. Pretty useful if you want to try to save a little bit of money. 7 pounds, 4 ounces converted to ounces. Just convert the pounds times 12, and then add the 4, which is longer, 12 meters or 3 yards. Okay, just use the convert one to the other and see which one's bigger. A car is traveling 55 miles an hour. What's the car's speed in feet per second? Let's take a look at this, right? 55 miles per 1 hour. Okay, so now there are 5,280. Whoops, look at the mistake I just made. 5,280 feet in 1 mile. Now they cancel out and they're in the right place. And multiply by 3,600 seconds in 1 hour. Now the hours cancel out because they're on one's on the top and one's on the bottom, and we're left with feet per second. Okay, and then you just have to multiply. Not a unit rate because that's not 1. That is a unit rate per 1 day. So that is a unit rate. Does multiplying by a conversion factor change the amount of what's being measured? No, because all of our conversion factors are always 1. That 1 hour is the same as that 3,600 seconds. That's the point of these things, is that you always are multiplying by 1. And finally, if you convert pounds to ounces, will the number of ounces be greater than or less than the number of pounds? Well, ounces weigh less than pounds, so ounces will always be more, right? There's more ounces in a pound than pounds in an ounce. Okay, so you're always going to have, it's still going to be the same weight, but it's going to be more ounces. Okay, and that was 2-6 ratios, rates, and conversions.